Okay, welcome to the first week of the second 6 weeks. This is your wind form review. We're going to be going over that first homework packet for week one. And I wanted to start by talking a little bit about this initial section on the vocabulary, just to give you some suggestions about things that you could change possibly if you're getting points off on this first section. A lot of people are getting points off because the posters are all in one color. They're not adding any color to them, or maybe they're not following the directions for the Frayer model, which is that each of these sections should be like the example here. If you look at the very first week I ever did, I went over the Frayer model and talked about what each section should look like. So you can go back to that very first week one video and it'll give you a really good description of what kind of things you need to be putting into these boxes along with an example to help you figure that out. The last thing about this first section of vocabulary, some people are actually not making it larger than a sheet of paper, and that's another place where you can get points off for this. So real easy grade for this first part. Just make sure that you follow the directions and knock that out. Again, it only needs to be for one of the vocabulary words for Newton's laws, and you can see up here that the choices are the first, second, third law of motion. You could go with the Newton as a unit, force, free body diagrams, inertia, Sir Isaac Newton, G-force, action-reaction pair, net force, and then air resistance. In the second section, I've seen some really good flashcards from people, and I think that for the most part, the flashcards, I haven't really had to take any points off. There's no color requirements or artistic elements to this, and the only thing that's different is that you have to do a flashcard for each word. So just make sure you keep doing what you're doing with that. A lot of people are doing the flashcards are doing them correctly, so no one's really been getting points off for that. When you go on to the first part of your work section, which is going to involve some notes that we've actually done in class, and then we've also got some example problems here that I'm going to do with you. And those example problems got loaded for us right here. The first one says Victoria the Valiant pushes to the right with a force of 45 newtons, while Felicia the Fearless pushes to the left with a force of 40 newtons. Find the resultant vector. So what we're going to be doing with these problems is creating a force free body diagram where we show all the forces that are acting on the object. And in this case, you have two different forces. You have a force to the right of 45 newtons. And we're going to try to show these qualitatively the right size. So I'm going to show that this 45 newtons is slightly bigger than the 40 newtons. So that's 45 newtons to the right from Victoria the Valiant. Then you've got 40 newtons to the left. And when we try to resolve the vectors here, remember we discussed to make this easy when we're trying to find the net force on this object. We're going to make sure that we subtract because they're going in opposite directions. The other method would be to add them and then put the signs depending on which direction they're going. We're going to go with the subtraction method because it looks like for the most part that's something that a lot of people have caught on to very quickly. And we're going to always go right minus left, so we get the right sign on our net force. So in this case, it would be the right force of 45 newtons minus the left force of 40 newtons. And that gives us a total net force of 5 newtons. And because it's positive here, that tells us that it's going to the right. Again, net force is a vector quantity, so in addition to giving the magnitude, which is the 5 newtons, you also have to give the direction, which is to the right. Okay, looking at the second example for that homework, it says, in a local football game, Mauricio the Marauder runs directly north for 25 meters, then turns to the east and runs an additional 20 meters before getting tackled by Jacob the no-hit. What is the magnitude of the runner's total displacement? So they just need the magnitude. We don't have to put direction here. And if we actually show the direction of this person running, this isn't going to be a free body diagram. I'm going to do that. This isn't going to be a free body diagram. We're actually just looking at distances here. But it can be applied to free body diagrams the exact same way. So if you have this object, this person running, they initially run, again, I'm going to do this qualitatively so it's about the right size. So 25 meters north, And then from this point, he turns east and runs 20 meters. So when we're doing this, you can see that this actually forms a right triangle. And we can use the Pythagorean theorem to find this resultant vector right here. And we do that using the equation a squared plus b squared equals c squared. And that'll give us the resultant vector that's formed between these two um, distances that have been traveled by this football player. The important thing here to understand is that we know to use the Pythagorean theorem here whenever we have this perpendicular vectors set up. Wherever you have one vector that's going one direction and then a perpendicular vector together on one object or one thing that's happening, we know that we're going to have to use this Pythagorean theorem because it ends up forming a right triangle. So when I plug these two values in, it would just be 20 squared plus 25 squared equals c squared. 20 squared is 400 plus 25 squared is 525 equals c squared. It's going to be 925 take the square root of both sides, and that'll give you your magnitude for the resultant vector here. I need to make a correction here. So this actually is going to be 625. 25 squared is not 525. After I said that, I went back and double checked. It's 625. And so 625 plus 400 is 1025. And you take the square root there, and that'll give you your magnitude for the resultant vector in this example. Okay. The second part of the work form gives you some diagrams with this little car, and they do add in some other important information that you'll have to include in your free body diagrams. So on number 1, it says, let's assume the wheels of a 5-kilogram car apply 10 newtons of force. What is the net force if friction and drag are negligible? So if they're negligible, that's a new word that we haven't really discussed in class at that point. Negligible means that you don't have to take them into account. They're so minimal, they're not impacting the net force of the object. So when we draw the free body diagram for this first example, you're going to have a 5-kilogram car, and we're going to have a force, in this case to the right, of 10 newtons. So 10 newtons of force going to the right. Again, we're assuming that there's no force of friction and the air resistance is negligible, so it doesn't exist. And that leaves us with a net force of just 10 newtons. So in this case, there's no opposing force. We don't have to subtract. There's no force in addition to the force being added to the wheels of the car by the engine. So it's just going to be 10 newtons. And because it's positive, we know it's going to the right. Again, vector, so it has to have direction. But number 1 is this simple, and it doesn't have to go into any more detail. For 2 and 3, you do have to take into account if they're going opposite directions, you subtract, and if they're going in the same direction, you add. Okay, so all the problems on this first homework are all about, the free body diagrams that we've been covering in class throughout the week. For this first week of the second 6 weeks, as we're introduced to Newton's laws. Make sure that as you go through them, you pay close attention to the direction of the forces and the signs that you get on your answers, because that sign gives you a lot of information in dealing with the direction that your force is actually going, your net force. And then the final thing I want you to pay attention to is on this nurture part, there's still people who are filling this out for themselves. It's very important that on this last part, this last section, that you actually have somebody else fill that out. You'll teach them all the information that you've learned by doing your homework, and then they're going to actually answer these questions about, their discussion with you and how well they feel like you understand the information. So make sure that you go through the process correctly and have them fill this out for you. And that's the end of this first week. If you have any questions, again, my tutoring hours are going to be Monday, Wednesday, Thursday, and Friday in the morning, and then every afternoon except for Wednesday until 4:50.